Welcome to Professional Car Washing and Detailing Wash Talk. I'm your host, Brian Ankney. Today my guest is Stuart Hammerschmidt from Shore Corporation. Welcome, Stuart.
How are you?
I'm doing really well, Where'd you come in from today?
About a mile and a half down. I spent the night locally, but I'm from the Pittsburgh area.
Oh, nice. That's not that far away.
No, it's about an hour and 45 minutes.
Yeah. Well, hey, I want to get started with a little bit about yourself. Not the Steelers. Not that you're a Steelers fan, but everything else. Tell me a little bit about yourself and the career path that led you to where you are today.
Okay, I have a degree in chemistry from the University of Pittsburgh.
Mm-hmm.
My first job was Westinghouse Environmental and Geotechnical Services. I was an environmental consultant. And then a recession hit, and the first thing they do is get rid of the consultants. So I was unemployed, and there was a gentleman that my mother knew that was looking for a chemist.
Mm-hmm.
My mother's like, I know a chemist. So I started working at Shore for quality control. And at the time, Jack Shore had just sold the company, and he was the founder of Shore Corporation. It was Shore Chemical at the time. Once he sold it, it became Shore Corporation. And they sat me down next to Jack and said, everything that he knows, you learn. And Jack was a bench chemist, and everything that he knew, they don't teach you in class. This was all new stuff. He would basically formulate in his head, walk into the lab, mix something up in a beaker, go test it on a car or a building or a wall or whatever. And I knew all the nomenclature. I knew what all the ingredients were. I didn't know anything about putting them together.
Mm-hmm.
So he taught me that. And, you had customers that owned car washes, and they'd be like, well, I need something that can do this. And I formulated differently than Jack. I would formulate based on cost first. I mean, anybody can make something that's effective, but is it affordable?
Yeah.
So I would formulate on paper and say, okay, it's going to cost this much. Well, half the time people are like, no, I don't want it. So a lot of the questions that I would ask is, okay, what do you want it to do? How much are you willing to spend? Because if I can't figure out how to make it affordable, then I'm not going to waste my time making it.
Mm-hmm. Makes sense.
So I've been doing that since then. And then the same person that hired me said, you should get an MBA. And I'm like, MBA? He goes, we'll pay for half of it. I'm like, okay, I guess I'm getting an MBA. So I got an MBA also.
Awesome. I thought you said the NBA. No, I'm
No.
just kidding. Neither one of us is tall enough to do that.
No, absolutely not.
Well, I do want to talk about some chemistry and some chemicals here in a bit, but I want to start with water. How can a car wash, what should a car wash owner consider when they're deciding whether or not they need a water reclamation system?
Well, there's several thoughts when it comes to the water reclaim system. A lot of them are feel-good marketing points. If you're driving past a car wash and says, we use all reclaimed water, that's a good marketing point. If you're in a desert and you're only given X amount of water to use, it would make sense to keep reusing it. I had a customer that was in Park City, Utah. Water was extremely expensive because it had to be pumped all the way from basically Salt Lake City all the way up the mountain.
Mm-hmm.
So he would collect snowmelt.
Makes sense.
And he had 5 or 6 tanks of 20,000 gallons each, and he would collect all the water and keep reusing it. And that was very effective. If you're in a place like Florida where the water table is below sea level, then it makes sense to reclaim the water. But if you're in a place that has cheap water or water's readily available, let's take Cleveland, for instance.
Mm-hmm.
You have a big giant lake. You're not pumping up a hill. You're not in a desert. Water comes out of the lake, goes to a treatment facility. Treatment facility cleans the water, sends it to the car wash. Car wash uses the water, goes to the sanitary authority. Water gets cleaned again, goes back into the lake, cleaner than when it was coming out of the lake. Mm-hmm. That's a reclaim system. The municipalities have already built water reclaim systems. You are effectively reclaiming your water when you send it to the sanitary authority. Mm-hmm. So you have to do the math. Does it make sense to put the investment for a reclaim system in? If it's going to save you money, then go ahead and do it. But if it's not going to save you money, you already have a reclaim system in place.
That's interesting. I hadn't thought about it like that. So, I mean, basically, we're in Akron, so every drip of water in this, well, this was from a bottle, but let's say we got it out of the tap.
Right.
So every bit of water that enters this building may have made that cycle several times. It got pumped out of Lake Erie. It got cleaned. It came here. It got used. It went back to a treatment plant, and then went back into Lake Erie, where it may have gotten pumped back in again. So Lake Erie is like our reclamation system.
Exactly.
Interesting. I never thought about it like that. Let's shift gears, and this is kind of an off-the-wall question. I've heard that you are now in the solar panel cleaning business.
I am.
You're in a lot of businesses, but it's mostly cleaning. It's always cleaning. But
it's always cleaning.
How in the world did you find out that you wanted to be and could be in the solar panel cleaning business?
Well, I developed a product that was my wife's idea. Mm-hmm. She said, you should make a product that you can spray a car and the rain washes the car. I'm like, okay, I can do that. Because there's 4 types of car washers. There's people that go to the tunnels, people that go to the in-bays, people that go to self-serves, and people that wash their own car in their driveway. This product is for the 5th car washer, the one that doesn't wash the car at all.
And that's me. That's me.
So the premise was, walk out, storm's coming, spray down the car, walk away. Let Mother Nature do it. So I even got the words rain wash trademarked. Mm-hmm. Rain space wash trademarked. Well, we couldn't get any traction with it. We tried it on Amazon. We tried it with Walmart. Just couldn't get any traction. So my one sales guy took it to a local university because he knew the maintenance director. And he goes, have you ever tried this on a solar panel? He's like, no. So they sprayed it on a solar panel, and because the university owns the solar panels, and they have all the data of the output from all of them, he sprayed down one, and the efficiency went up by about 15%.
Wow.
Because they'd never been cleaned. And the solar panel companies say, okay, it's maintenance-free, just put them out there. Well, there's no such thing as a 100% efficient solar panel. It doesn't exist. It might exist in the lab, but it doesn't exist in real time.
Yeah.
So the minute you plug it in, you're at 90-something. And then it gets to 90, gets to 80, gets to 75, because you get organic film, debris, dust, dirt, whatever. Eventually, will just start sticking to it. It's no different than leaving your car out in a parking spot for 6 months. It's going to get dirty just by sitting there. Mm-hmm. Well, spray it down with the rain wash, which was designed to be on a glass or metal surface without harming it for as long as necessary. And it was pulling that film and debris off the solar panel. And it increased the efficiency. So the plan now is we're trying to go after these solar panel farms. Because, these things are acres and acres of just solar panel arrays. And thanks to COVID, there's a new way to spray it. When all of the stadium arenas had to be disinfected before games for all the fans to come back, some guy developed a drone to spray disinfectant in the stadiums. Well, we're trying to work with this guy to put the rain wash solar panel cleaner in the drone, and then you could have the drone just spray over the solar panels.
It's interesting. Now, how much like actual volume of rain wash would go on, say, a panel like the size of one of these? Like would the drone be flying with like, the product inside of it, or would the drone be flying with a tank behind it, or would the drone actually maybe not be flying? It would be on tracks and be spraying. Like, have you thought about like what this drone will look like?
The one that we were looking at originally was a flying drone, because a lot of these solar panels are on the tops of buildings.
Oh, yeah.
So solar panel arrays, yeah, maybe we will be going after a drone like a farmer's tractor, where it's just driving down, doing that. But for the time being, we were targeting the solar panels that are on the roof that nobody can get to.
Oh, yeah.
But general rule of thumb with a coating is you can get about 200 square feet per gallon. So if you're going to coat a driveway with a water repellent, general output is 200 square feet per gallon. So for something like this, you probably need it to plate out. You could probably get as much as 300 to 400 square feet per gallon.
Mm-hmm. Well, so I mean, you're talking a serious amount. I mean, you're talking about more than this entire thing behind us with
a single gallon.
With a single gallon.
Yeah.
So I mean, so the drone, even on a large building, it may only need to refill a couple times, and it's a drone, so it's got the time, right?
Yeah, it's got all the time in the world.
Yeah, it's got the time. All right. Well, I want to ask you about. We're going to go back to car washes, but we're not going to go back to washing cars. Let's talk about.
Okay.
All right. So, if you're driving down the road and you see a clean car wash and a dirty car wash, you're probably going to pick the clean car wash because you assume that the clean car wash is going to clean your car better. And it is important, especially if you're trying to build a brand, have your facilities look good. You also have helped with chemistry to clean the actual wash that washes the cars. Can you tell me a little bit about that?
Well, we have a whole line of building restoration products.
Mm-hmm.
So we clean buildings, we clean glass. I like to tell everybody it's easier to clean a building than a car because the building doesn't move.
Yeah.
But a lot of these car washes they're either brick, they're metal, they're glass, or there's something similar to stucco called EIFS. And you can get a lot of calcium buildup on glass from hard water. And that's the white stuff that just, like soap scum. It just doesn't look good.
It's on everybody's shower in America.
Right.
Unless you've got a really good water softener.
And I do. But the calcium buildup, we had developed a product to remove something called efflorescence. And if you've ever seen a brick building where that white is just stuck to the brick.
Mm-hmm. I have.
Okay, that is calcium also. It's leaching out of the mortar. So since it's calcium and we developed a product that could remove that, you can also use this on the glass to remove the calcium buildup of the soap scum or, the other impurities, magnesium or whatever else is on the glass. Car washes are very wet environments, and a lot of time you'll get moss or mildew or something growing along the base or near the exit or near the entrance. So aggressive alkaline or acid cleaners will remove the mold or the mildew. A lot of times in the parking lots, you will have oil stains where the cars have been parked where they're using the vacuums. We have a product that's a microbe that will eat the oil out of the concrete.
Oh, that's cool.
So, yeah, it's organic.
Yeah.
But you also have to clean the concrete. So we have a product to clean the concrete, open up the pores, and then pour this product on, walk away. And as long as it doesn't freeze and they have food, they'll keep eating it.
So what do you do when it's done? Do you prevent it from coming back, or do you just do the same process again? I mean, because if people are going to keep using those vacuums and they're going to keep dripping oil, like, or would those same things that were eating the oil, like if you put them in the spring, would they last all the way to the fall? Or?
Yeah.
Really? That's pretty cool. So they're just like waiting.
Yeah.
They're waiting. So when that oil drip hits, they're like right on it.
Exactly.
That's cool.
So they'll either die off due to freezing. So once it gets below 32, that'll kill them. Or if they run out of food. So if the car wash shuts down and there's no more cars, eventually they run out of food and they'll starve.
Wow. That's pretty neat. So, so you can put them down in the spring every year and they'll take care of you all summer.
Yeah, and you can use these for drive-throughs like, gas stations, restaurants. Put it anywhere. Bank drive-up machines, anywhere where you've got oil stains that happen likely, and that's usually like a toll booth, wherever the car is sitting for an extended time period.
I think I'm gonna have to get a bottle of that from you, because where I live, the people park in front of my house to go to the beach, and so like from the time it's warm to the time it gets cold, there's no in front of my house is all cars, and I have some of that oil stain on the street, and so if I just put that down in the spring, I wouldn't have the oil stain on the street.
I'll bring some with me to Atlantic City.
Awesome, we'll do it.
There we go.
Yeah, my wife's gonna be really happy about that.
Until you tell her that she has to do it.
Well,
no, I'm kidding.
She would laugh longer than you just did. Well, before we get away from the buildings, I just want to ask you about a really unique story that your business did in Washington D.C. Can you just tell me a little bit about that project that you did in D.C.?
Well, we cleaned the exterior part of the exterior of the U.S. Capitol. I told everybody, I said, we couldn't do anything about the inside of the Capitol. We could only clean the outside.
Only clean the outside. You can put some of those microbes in there, let them eat everything they find.
They would not starve, that's for sure.
Yeah.
But the architect of the Capitol, which is basically the entity that determines what can be used on the Capitol, has a mantra, whatever you want to call it, of do no harm. So this is one of the few instances where cost is irrelevant. You have one of the most iconic structures in the world that's recognizable. They need it to be cleaned and restored, and they want nothing done that's going to harm the building. We had developed a product for cleaning copper stain out of marble, limestone, sandstone, whatever. But in order for that product to work, we needed a poultice in order to do that. So you would soak the chemical in the poultice, apply the poultice to the surface, and it would react with the copper in the stain, convert it to a different level of copper. I won't bore you with that detail. And it would make it water soluble and extract it out. Well, somebody at the architect of the Capitol figured out that if you soak the poultice just in water and apply it to the marble, it was pulling dirt out of the marble. Well, that's neat. So they started using it on the ornate structures of the Capitol, like the statues that are 7 stories up, to pull the contaminants out of the statues.
Well, that's really cool.
And so I actually got to be on the Capitol for one day.
That's awesome.
Which was really neat, because my favorite picture from the experience was I'm standing on the roof of the Capitol and I took a picture of the Washington Monument.
That's awesome.
So I'm eye level with the Washington Monument.
Oh, that's really cool. Well, I saved the hardest question for last. I've been hearing graphene. Everybody's talking about graphene.
There it is.
Oh yeah. I'm surrounded by graphene. All right, let's start at the beginning. Can you tell me what it is, how it's made, what it does? Give me the lowdown, or as my directors would say, spill the tea on graphene.
I brought props.
You brought props. Let's see them.
Chicken wire.
Yes.
Painted black. So, look familiar?
It does.
So this is graphene, or a representation of graphene. Graphene is all carbon, 6 atoms, all attached. They are quasi-double bonds. Now, some are going to say, what do you mean by quasi-double bonds? Because it's a ring structure, the electrons are fluid. So if you were to measure, in theory it would be double bond, single bond, double bond, single bond, double bond, going in that direction. But if you were actually to measure it, it's kind of like 1.5 bond.
All the way around?
All the way around. And it's very, very secure, and it's very, very strong. And it's 1 atom thick. So I painted another one white, just so you can see. But when you take graphene like this, and you stack it like this, that is graphite.
So it's 3 layers of graphene.
No, it's much more than 3. It's hundreds, thousands, millions.
Oh, okay.
So if you have a pencil, that's graphite. When you write with the pencil, you're stripping those layers off and leaving a mark on the piece of paper. So effectively, you're writing with graphene.
Yeah, so if you could write with one layer, it's graphene.
Right. But usually with a pencil, you're going to have more than 1 layer. It's going to be 2, it's going to be 3, it could be 10, it could be 20, 30, who knows?
Yeah.
You need an electron microscope to figure out how many layers are on that piece of paper. So graphite is the crystalline structure, 3-dimensional, of graphene.
Okay, gotcha. Graphene is 1-dimensional. It's only one.
Graphene is 2-dimensional. Graphite is 3-dimensional.
Oh, okay. Yeah, okay.
Now, there's another version of graphite called graphite oxide. So if you have these end parts that are not attached to anything, and you react it with a strong acid, like sulfuric or nitric or aqua regia,
Yeah.
which is a mixture of hydrochloric and nitric, you will oxidize parts of the carbon with either a carbonyl group, which is a carbon double bonded to an oxygen, or a hydroxyl group, which is an OH group, like half of water. So it'd be carbon, oxygen, hydrogen, or it'd be carbon double bond oxygen.
Okay.
That's 3-dimensional version. You can also take the 2-dimensional version, do the same thing, and then you have graphene oxide. So these endpoints would be oxygen or OH or whatever.
Mm-hmm.
And then back to pure form again. They first discovered graphene in 2004. They always knew it existed, but they didn't realize it was a single layer. And the way they determined it was a single layer, it's called the Scotch tape technique. They took graphite and they put tape on it and they pulled it off and got a single layer.
Really?
So that's how they were producing graphene. Mechanical. They've figured out a few ways to make it since then, but the amount that you can make is very, very, very small. So you can 3D print graphene, but it's about 5 to 10 millimeters in size. So you're talking, less than 1/4 of an inch to maybe 1/3 of an inch. That's how big they can do with a 3D printer.
So for one sheet, it's like there'd be one sheet, but it would only be this big.
Yes.
Wow.
The other is to take graphite, react it with your strong acid, which is making your graphene oxide. Then you have to dissolve it in that acid solution, so it's dispersible. Then you have to filter it. Then you have to dissolve the filter so that all you're left is the graphene oxide.
Okay.
So it's like if I took this piece of paper and the black is the graphene and the white is the filter, you need a substance that's going to dissolve the white without attacking the black. Mm-hmm. So that will be a single layer. And then you have to react the graphene oxide with hydrazine, which is similar to ammonia. So it's a nitrogen compound and it's a hydrogen compound, and you're stripping off those oxygens to make it graphene. There again, very, very, very small scale. So we're talking, there again, maybe an inch. Mm-hmm. It's not very large. The third way, which is the easiest way probably to make large scale, is to take methane, which is carbon, 4 hydrogens, in the presence of copper plate, and heat it up to 1,000 degrees centigrade, which is 1,832 degrees Fahrenheit. It strips off the hydrogen and plates out the carbon onto the copper. They found a cooler reaction, and when I say cooler, it's temperature. When you add nitrogen into the equation, you can drop the temperature down to 420 degrees Celsius. And that's how you will plate out graphene onto copper. So, it's not that easy to make. And once you break apart the graphene into little tiny bits, you end up with bits of graphene, and they don't go back together again. You have to put it into a huge amount of heat or chemical reactions for it to do that. So it's not easy to make, and it's very difficult to work with. And it's not water soluble.
So I'm waiting for the happy ending here.
Well, the happy ending is this stuff is incredibly strong. It conducts electricity phenomenally because these bonds are fluid. You can basically take an electron and just zip it across.
Zip it right across.
Right. So if you could make electronics, which they're working on, there are phone companies that are working on plating the graphene in between the films to increase the speed and increase the life of the batteries.
I mean, if I'm understanding you right, because these are all fluid, I put one electron in here, and it's almost like bouncing like a bunch of pool balls in a row.
Right.
Boom, 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 boom. So as soon as one hits here, the other one comes out here. It's a different electron, but this one replaces that one, which replaces that one, which replaces that one, all at once, instantaneously.
Exactly. So
the other side.
It's highly efficient,
Wow.
and it's very strong. So some of the things that they're using, well, they're experimenting with, material science. So they're actually experimenting with putting it in concrete. Concrete is a very, very dense and heavy material. If you have something that's super, super strong that you can replace some of that concrete with,
Use less concrete.
and it would be lighter.
But hopefully you never have to tear it down, right?
Well, the good thing is, when you break the concrete, you're not breaking the graphene, you're breaking the rest of the concrete. We're talking about using very, very small amounts of graphene in order to do this. Microelectronics. So if you had, say you had a pacemaker, and you could incorporate graphene into the pacemaker, it would last longer, it would be more efficient, it would use less energy. That would be very useful.
Yeah.
Batteries. I mean, because those electrons can move so quickly, if you incorporate graphene into batteries, the batteries are going to be more efficient, they're going to last longer.
Maybe create less heat because there's less resistance, right?
Exactly.
Wow.
So you could have, they call this a supercapacitor because the energy is so efficient when you move through it. They're thinking about using it in solar panels. It would improve the efficiency, it would make it lighter. So you're replacing certain parts of the lithium, which is expensive, difficult to get with this. They're experimenting with it in paints. Now, if you put it into an automotive paint, imagine what it could do. Maybe the dirt wouldn't stick.
Wow. That's dangerous.
Well, you're always going to get something to stick eventually.
Yeah.
You're still going to need water to get it off.
Yeah.
Other electronics. But, I mean, there's lots of possibilities with graphene. The biggest hurdle right now is getting it to a large scale. There is currently not a large-scale production of graphene. It's not there yet. But they've only been playing around with it for almost 20 years. So maybe in the next 20, it might be in everything.
Wow, yeah. I mean, especially with the transition our country's going through to EVs, and I mean, it seems like if you could eliminate the cobalt from the EV battery, which just helps to keep it cool. I mean, if you could eliminate some of that heat, make it more efficient. I mean, you could solve a lot of problems that America's having right now. You could get more distance. You could get faster charging. You could get less heat creation. You could get lighter batteries. I mean, those are like the big four problems. That's exciting.
Yeah. So yeah, I've been doing a little bit of experimenting with it, but it's not very good for a cleaner. So I'm probably not going to play with it that much.
So it's not effective yet.
Right.
As a cleaner for vehicles.
As far as I can tell, no.
Okay. But maybe at some point when there is a large scale application, it could be something similar to like a ceramic treatment that you would have put on your car. I mean, is that
I don't know.
If you could mass produce it and you could reconnect it and you could find a way to apply it, it seems like it would be the ultimate protector, right?
In theory, but I don't see how you're going to connect it. I think you'd probably have to incorporate it into the automobile itself.
Oh, gotcha. Stuart, thank you for coming in today.
Appreciate it.
I really had a good time learning about the graphene. I had no idea. And before we go, I would just like you to show your Scooby-Doo tie to the audience.
There we go.
If you want to talk to Stuart, he's at just about every trade show, and he wears that tie at least one of the days.
At least once.
Thank you for taking the time to join us for this Professional Car Washing and Detailing's Wash Talk. I'm your host, Brian Ankney. Today my guest has been Stuart Hammerschmidt from Shore Corporation. We hope to see you again soon.